whenever we solve a polynomial equation, basically what we're doing is we're trying to find the number of solutions, the number of zeros, whatever you want to call it. Okay? The roots, same thing. All of those mean the exact same thing and have that same value, just depending on what your graph or what your equation or what your polynomial is. Okay? So it's not as simple as it's a quadratic like it has been before. Okay? Whenever we were back in chapter 2 and chapter 3 and solving there, is now we're going to get into cubes, fourths, things like that. So the question kind of here is, how many solutions does each graph have, and then what type of solutions are they? So if we look at just the one here on the left, how many solutions do I? Let's just answer the first question. How many solutions do I have? From what you remember, okay, how many solutions do you think I have? Or think about it this way, am I going to have an odd number or an even number of solutions? An odd number of solutions. Okay? Why an odd number of solutions? Because it changes 3 times, right? And it's going in opposite directions. Okay, so if I would kind of continue my arrow here and there. So I'm going to have an odd number of solutions What's one of those solutions? What's one of those zeros? If you need to look at it up there, it's counting by twos. So it's like 0, 2, 4, 6, and then 0, negative 2, negative 4, negative 6. So what's one of my solutions? What? I heard negative 3. And then 2. Do I have an odd number of solutions? So where's the other one at? Any ideas? Negative 3 is right. 2 is right. What? Any ideas on where my third x value is? What about 2 again? Why 2 again? What does it do? What does my graph do at x equal to 2? It lands and then it goes right back the other direction, right? Okay? So anytime you have a directional change, if it goes from decreasing, in this case from decreasing to increasing, or if it goes from increasing to decreasing, and it's on the x-axis, then that's going to equate to 2 of the same solutions. Now, whenever we actually solve this, you're going to get x equal to negative 3 and x equal to positive 2. Okay? It's just that you have to know that, hey, 2 of those values or 2 of those solutions are eaten up by one value. Okay? Because it makes that change, it changes that direction at that value. So then, as far as my second question, what type of solutions are they? Okay? So this is what we would call, basically, would be a double root. Okay? Double meaning 2. Okay? Root is just another word for like solution, a zero, whatever. Okay? X-intercept. Okay? All of those things mean the same thing. It's just a matter of the context in which you're talking about it. Okay, so whenever we talk about solutions, or when we talk about zeros, or we talk about x-intercepts, we talk about roots, all of those mean the same exact value. So if I have a solution of negative 3, I have a root of negative 3, I have a 0 at negative 3, or I have an x-intercept at negative 3. Those all mean the same thing. Okay? It's just a matter of the context in which we're applying it. Okay? So then, if you look at the value over here to the right, how many solutions do you have here? How many, or let me put it this way, how many solutions can you see? One. Okay, you can see one solution, right? How many solutions should you have? Somebody said it. Huh? Not one. Somebody said 3 back in here. No? Did you say 3?
No.
Oh. Okay. Why is it not 1? Why is there not one solution? Because it changes. It doesn't really change 3 times, but it's not a straight line. Okay? If it had only one solution, then it would look something like this. Okay? It would be a straight line. Okay? That is far from straight. That has curve to it, right? Okay? So since it has curve to it, you know, if it had one solution and it was through that same value, then it would look something like that. Okay? Since it's not a straight line, then it's going to have it's going to have more than just the one solution. Okay? It's going to have more than one. It's going to have at least 3. Okay? We're going to go with 3 as far as the number that we're going to have. So if we have 3 solutions, what's one of my solutions? What's the obvious one looking at it? Again, it's counting by 2's. Negative 3. Okay. So right there. So my one solution is going to be at x equal to negative 3. Is it ever going to cross the x-axis again? No. So I have one real solution. What are the other 2 solutions going to be then? Close. Huh? If one of them's real, where's the other one at? 2. Two are imaginary. Okay? You have to have 3 solutions. Okay? It's at least a cube. You see one of them. So if you don't have any other ones that where it crosses the x-axis, then the other 2 have to be imaginary. Okay? If you can't see them, okay, if you know, just by knowing what you know, as far as it's not a straight line, so it can't be to the first power. So it's at least to the third power because it's going in opposite directions. Okay? Then one of them you can actually see. One of those is real. The other 2 have to be imaginary. Because, okay, they're imaginary because you always have a positive and a negative version of it. Okay? So you will never have, okay, so before you think this, you will never have an odd number of imaginary solutions. Okay, so if you need to put that somewhere and just kind of a note that just so you can, you know, you'll never have an odd number of imaginary solutions. You'll either have 2, you'll have 4, you'll have 6, you'll have 8. More likely than not, everything from here on out, for the most part, you're going to probably, if you have any imaginary solutions, you're going to have 2. Okay? There's not, very rarely, if at all, will I give you a problem that you'll have more than 2 imaginary solutions. Okay? But you should never have one solution, or one imaginary solution, or 3 imaginary solutions. Okay? That's kind of like the graph right before it, where it's that double root. I'll have some students that'll say, well, one of those has to be imaginary. No, it turns around at that point, so that's why it eats up 2 of my real values. Okay? So whenever we solve a polynomial, okay, whenever we actually get into solving it, so it says that 2x to the third minus 12x squared plus 18x equals 0. Okay? So if we want to solve it, basically what you're going to do is you're going to factor everything out. For right now, you're going to factor to see if you can. So if I can factor, what can I factor out of 2x to the third minus 12x squared plus 18x? 2x, right? So if I can factor out a 2x, then I have x squared minus 6x plus 9, and then equal to 0. So it's kind of like that factoring completely, right? So I want to factor this thing completely. Can I factor what's in the parenthesis? Can I factor x squared minus 6x plus 9? Are there 2 numbers that multiply together to give me a positive 9, combined to give me a negative 6? Yeah, what are they? Negative 3 and negative 3, right? So I have x minus 3, and I have x minus 3. So if I'm going to solve these, what do I need to do with each single part? What do I need to do with the 2x? What do I need to do with the x minus 3 and then the other x minus 3? Set them equal to 0. Okay? So if I set each one equal to 0, so if I set 2x equal to 0, and I set x minus 3 equal to 0, and I set the other x minus 3 equal to 0, what are my 3 answers? What are my 3 solutions? 0, 3, and then 3 again. So here are my solutions. So what does that tell me? Okay, what do these solutions represent? Okay, where the graph does what? Either crosses or changes directions at the x-axis, right? Okay, so as far as what does it do? When does it cross the x-axis? It crosses the x-axis at x equal to 0. What does it do at x equal to 3? Changes directions, right? Okay, so it changes directions. Okay, you may put changes directions, you may put turn around, okay, at x equal to 3. Because I got x equal to 3 twice, that's where it's going to change direction. It's just going to go through 0. Okay, but it's going to change direction. It's going to land and take off. It's going to be, basically it's going to be this blue ball, okay, when it hits the table. Bless you. Right? It's going to hit that table there at 3, and then it's going to take off going back the other direction. Okay? So, same thing. Now I have f of x is equal to negative 2x to the fourth plus 16x squared minus 32. So, what can I do to each? What do I need to do with the f of x? What do I need to turn it into? What value do I need to give it? 0. Okay? So, if I give it 0, what am I going to do with everything else? If that's 0, what can I factor out of every single part here? Okay? 2, I would factor out a negative 2. Okay? Because this lead number right here is negative, I would factor out a negative. It's just going to be easier to factor. So then if I have x to the fourth minus 8 minus 8x squared plus 16. Again, just kind of goes back to that completely factoring. Can I completely factor this? Can I factor out the x squared, or the x to the fourth minus 8x squared plus 16? Can it factor again? Yeah, but instead of, since it's an x to the fourth, right, it's a negative 2 still. What's going to be the first term in each parenthesis? X squared and x squared. So two numbers that multiply together to give me positive 16 and combine to give me a negative 8. Negative 4 and negative 4. Now, it's still that whole completely factoring, okay, that we talked about in the beginning part of chapter 4. Can I completely factor x squared minus 4? Yeah? Into what is going to happen with each one? X plus 2, x minus 2, right? And then x plus 2, x minus 2. So then what are my zeros? What are my solutions? What are my roots? What are my two answers, essentially? What is x equal to? What's x equal to here? X is equal to negative 2. What's x equal to here? X equal to positive 2. What's x equal to here? A negative 2 again, right? And then x is equal to a positive 2 there. Do I have to worry about anything with that negative 2? Not really, not right now. I will here in a second whenever we graph it, okay, or I sketch my graph. So I have 4 solutions, which I should have. Remember, this number right there is going to tell me how many solutions I should have. I have 4 solutions. But realistically, how many answers do I really have? I have 4, but how many of them? 2 of them are the same, right? So if I would write this as x equals positive 2 and x equals negative 2, aren't these really my 2 answers? Okay. Now, what does my graph do at those 2 values? Does it go through the 2 values, or does it turn around at those 2 values? It turns around. Okay? So it's going to turn around. It's going to turn around at x equal to negative 2 and x equal to positive 2. So as far as my sketch is concerned, really all I'm going to do, again, it is a sketch. I'm not really worried about a whole lot. I just know that I'm going to have 1, 2, there's 3, 1, 2, there's 3. I'm going to have a point right here at negative 2, and I'm going to have a point right here at positive 2. Now, here's where my negative 2 fits in. I know that this thing is going to take off and change directions at my 2 points that I put on my graph. Which direction is my graph pointed? Is it pointed up or down? Why? Because of the negative, right? Okay. Because it's to the 4th power, what do I know about both of those arrows? They're both going down, right? They're both pointing this direction. So what do I need to do in the middle? Make it look like an M, something. Okay? Now, just like before, what does that negative 32, before, like whenever we did with quadratics or whatever, what does that negative 32 tell me? Where it crosses what? You remember? The y-axis. Now, can you graph that, a girl? Okay. Are you going to be able to graph negative 32? No, everything pretty well goes to negative 10, right? That's why, again, it's a sketch. Okay? As long as you just show those two turnaround points and understand, hey, it's got to dip down to negative 32, come back up, and then go back down. Okay? That sketch is good enough. Okay? Again, it is a sketch. The biggest thing that I want, or the biggest thing that I am worried about, is right here. What is x equal to, and then what is it doing at those 2 points? Is it going through 2 or negative 2, or is it turning around at 2 and negative 2? Oh!